All right, we started section 10.6 last time, and we had gone through, and we'll just briefly revisit parabolas. We had talked about sort of the picture of what's going on, and we've got all these great equations that your book identifies for you, and we did this sort of from a graphical perspective as well. So they gave us some information, the focus and the directrix, and we created the equation for a parabola. You guys remember that? We're basically going to do this same process again for ellipses, and then we're going to do the same process again for hyperbolas. Okay? So ellipses are next. Ellipses, we can define an ellipse to be the set of all points for which the sum, that's an important word, we'll see that used later, the sum of the distances to two fixed points called the foci, the foci is plural of focus, is constant. Okay, so sum of the distances. We define the center of the ellipse to be the midpoint of the line segment connecting the foci. And there's another way you can describe that too with a little bit more language, but let me draw a picture first. I don't know if my tools will let me do. I think it will. Nice. Look at that. There's you an ellipse. You can draw an ellipse where it's sort of elongated on the horizontal axis, or you can draw it so that it's elongated on the vertical axis. And what changes is a little bit of the equation, but I'm going to do it different than the book does as well on how I change my equation. What's so funny, Micah?
I tried to draw that.
And it didn't work very well. Mine don't work. That's why I was really excited when it actually allowed me to draw an ellipse, because I don't draw very well either. Let me kind of show you a visual imagery of where the foci end up being. That's not very good. Let me try one more time. That's pretty good. So the foci end up making this look like a face with eyes, a little bit anyway. The center is halfway between them. So here's my center now in the middle. So this is my center. These points right here are my foci. And then your vertices, or your vertex, which may be on the next screen where I actually define them, but let me put where they are. They're actually along this particular direction, so it's the longer direction. We reference this line that connects the two vertices, goes through the foci, goes through the center, all of that. This is actually called the major axis. And if you went vertically on this one is called the minor axis. Your book doesn't really go into quite as much terminology as I just did, or at least not in the way that I've done it. But I know I'm going to fall back into saying some of these things. They're not complicated ideas. The major axis is simply the longer one, and it's the one that has the vertices on the end of it. And the minor axis is the shorter one, and that's it. The major axis has the foci on it, as well as the vertices on it, and the center on it. All of that lies on the major axis. Obviously, the center lies on both axes. Okay. And we can do the same picture over here, but as you can imagine, the major axis here is going to be vertical as opposed to horizontal. So my center, of course, is where they cross. The foci would be somewhere around right here and right here. Now, I want to label something else in this picture that we're about to see. Let me label the horizontal one first. The equation that we're going to do is going to call this length A, and it's going to call this length B. And C is actually the length that is between the center and the foci. Now, here's the deal. Your book changes A, B, and C in the other picture to mean something slightly different. I don't want to change what A, B, and C are. To me, that feels very counterintuitive. So what I do, and what I'm going to suggest we do, is that the vertical is still called B and the horizontal is still called A. C is still the distance between the center and the foci. Now, in some sense, yes, it looks like I changed something because, before A and C were along the same line segment, and now B and C are along the same line segment. But in terms of writing the equation and getting all the details in there, I think this makes more sense. And I'm totally being inconsistent with your textbook in doing it. I'm fully aware of that. Okay? So, in fact, so aware of it that there's a note on one of your other slides, so I'll say it again when we get there. But here's the picture we're going to go with. This is the one and only equation of an ellipse that I'm going to use. It says that we have x minus x0 squared over a squared plus y minus y0 squared over b squared, and it equals 1. To start with, the a value is bigger than the b value. A is greater than b. It's greater than 0. So they're both positive, first of all. This is going to describe an ellipse with foci at x0 minus c, y0, and x0 plus c, y0. So this is if you will, this is a horizontal ellipse. That's totally just made up terminology right there. It's the one that's going to be long, though, along the horizontal. So it's measuring along the horizontal because the x0 value is the one that's being manipulated to get the foci. You're going a little bit left, a little bit right of that. C is actually calculated as the square root of a squared minus b squared. And then the center of the ellipse is at the point x0, y0. The vertices are manipulated along the x-axis as well, or at least along the horizontal axis. So wherever x0 was, you add and subtract a. That's the picture that I drew. Wherever you were, you're a away, to the left and to the right. And you're at the same height, the same y value you were before. And then you see that phrase major axis, right? Major axis, the longer one. And then the endpoints of the minor axis can be found, there's that minor axis, can be found at y0 and then adding and subtracting the b value up and down. So this all fits in with the very first picture that was the longer along the horizontal picture that I drew. Okay, is everybody good with that? Okay, here's where it's going to differ between what your book does. What your book does next is it actually changes where A's and B's and things are and the definition of what they're doing. Here's my description. All we're going to change is we're going to let B now be bigger than A. So in terms of your equation, all it means is that the denominator under the y values is bigger than the denominator under your x values. Simple enough? You're just changing which of those denominators is larger. When you do that, it actually changes the foci. Instead of being from the x0 value out left and right, it changes it from the y0 value out up and down. So the foci are now vertically drawn instead of horizontally drawn. This is the second picture I drew, where I had what I'm referencing as a vertical ellipse, an ellipse that's drawn vertically. The center is the same place, x0, y0. The vertices go up and down from there, so they're affecting the y value. So you get the x0 and the y0, but the x0 stays stationary now, and the y0 is added to and subtracted from to get the top and the bottom points on your ellipse. And then the endpoints of the minor axis are found again by going left and right. So it's the a value left and right. So the beauty in doing this is that the axes don't change. And so let me let you write this down. And I've got my wonderful note here that says my labeling doesn't match your book. And I'm going to go back to my picture. So as soon as you guys are done with this screen, I'm going to go back to that picture that I drew before. Now, with very little exception, we're not even going to be referencing the x or a0, b, or a and b in reference to x0 and y0. But in terms of your picture, here's why I like this. This point over here on the corner is x0 plus a, y0, and it's that value no matter which ellipse, viewpoint we're on. And to me, that seems a lot more helpful than changing a and b's values. And that's what the book would do. And that's actually very typical. Most textbooks do it that way. They're going to change what A and B are defined to be. Well, I'd rather just A be the horizontal value, like we go left and right. And I'd rather B actually just be the vertical value that we go up and down. So that's how I'm going to define them. And you're going to see very quickly that it really doesn't matter because we're not going to be referencing the letters A and B as we do this. So let me take a look with you at an example and you'll see what I mean. All right, we're going to find an equation of a conic. This conic is an ellipse with some details. And this ellipse details tell us the foci and the vertices. So what I do first is what? Do you remember? I'm going to draw a picture. Why not? I mean, I've got this beautiful imagery here, and I can actually make all of my decisions without equations if I draw the picture, at least without as many equations. So I find that to be a helpful feature. So we're going to draw our axes. Everything's a positive value, so I really only need quadrant 1. My foci are at 1, 2, 1, 4. And then my vertices are at 1, 1. I'll just do them in a different color. I'll do them in red. And at 1, 5. The fact that they're telling you the vertices, that is, those red dots that I just drew, tells you that the major axis is the vertical axis, right? Now, here's the deal. What is the center? Let me do that first. What is the center of this ellipse? Yeah, it's this point right here halfway between, right? It's 1, 3. So in terms of writing my equation, I know I have an x value of 1 and a y value of 3. So this is x minus 1 squared, it's y minus 3 squared, and it always is equal to 1. That's just exactly how simple that is. The only thing that I actually have to calculate is I have to calculate what goes underneath x and what goes underneath y. Well, the y value is going to be the distance that I went from the center out to the vertice squared. So what is that distance? 2, and then if I square it, I get 4. So the value underneath the y minus 3 squared is 4. Now, I have to work a little bit harder to get the value underneath the minor axis value because the picture doesn't actually show this. Agreed? But we did have a relationship that relates A, B, and C. So if you will, what we've really got here is that the A value, or the major axis value, is, I didn't say it that way. A value is what I'm looking for here. My major axis, in fact, you know what, I'm not even going to use A, B, and C. I'm going to use it the way that we just described it. This value right here is 2. The difference, or the value right here that we called C, between the center and the foci is 1, obviously, right? So the formula that we have is that 1 is equal to the square root of the major axis squared, that's 2 squared, minus what I'm looking for, which is actually the A value in my picture. So if you want to call it A, call it X for all it matters. It really doesn't matter. It's the thing I'm trying to find. It's this piece right here. So I can solve this equation to figure out what in the world I need here. And again, it's really A squared, but this is squared here too, right? So if you want, this piece right here is exactly the number I write right here. I don't actually need the square root to find that. I'm not going to have to square root this, in other words. So if you take a look, what we've got is we've got 1 equals the square root of 4 minus, we'll call it A squared, which we're squaring on both sides. So then this is 1 equals 4 minus A squared. If I add my A squared and I subtract my 1, I get 3. So the number that goes right here is actually 3. Because it's the squared value that I need underneath the x minus 1 squared, not the square root of it. Now, in terms of a picture, this one didn't actually ask me to draw it, but I could finish drawing this picture now because I could take the center where I was and I could go out from the center exactly square root of 3 in each direction. So square root of 3 is about what? 1.3, 4, 5. It's a little bit more than 1. Agreed? So if we go out a little bit more than 1 in each direction, we're going to be somewhere about right here. And my ellipse looks something like this, which actually isn't too bad of a drawing for me on an ellipse right there. So we're going to have a moment here where we're going to be asked to actually make the drawing. We weren't here, so you don't have to do that, but if you wanted to, that would be the picture you'd get. Everybody good with that? Yeah? Okay. Next one is a hyperbola, and we're going to sort of approach this from the same perspective, but we don't have the weirdness of the labeling going on in this particular one. You'll see why. So we define a hyperbola to be the set of all points got left out. The set of all points such that the difference of the distances between the two, the two fixed points called the foci is a constant. All right, so the key idea here is that we're talking about the difference instead of the sum. When we did the ellipse, we used sum, and here we're using difference. Huh?
Our papers are right.
Your papers are right, yes. I'm sure that they probably are. I don't have quite the editing things to squawk at me within PowerPoint as you do within Word when you type things in, so that's probably why. Let me draw you a couple pictures. There's two ways that this can look. It can look like this, and these images go on to the left and to the right. Or it can look like this. I'm going to draw you a few pieces in here in terms of the labeling. First of all, these points right here that are the sort of the smallest and largest, if you will, along the curves themselves, those are called the vertices. Okay? So those red dots are the vertices. I'll use some color coordinating here. The center would be halfway in between. So far, so good, right? Sort of the piece that makes everything symmetric. So in purple is my center. There are foci in these, and they are sort of inside of what appears to look at least a little bit like parabolas. These are not parabolas, but you have that same sort of a feel going on in how they're opening. So the foci are these blue dots that I'm drawing. They might almost look black on the screen as they're playing out, but they're actually blue. So these are my foci in this blue color. Now, in terms of what we're about to work with in an equation point of view, it might be helpful to know what these values are measuring. So they're going to measure the value here as A. So the A value is the distance. Make sure I wrote that down right. Yep, the distance from the center to the vertices. Okay. And then if you take the distance from the center all the way out to the foci, that's actually what they're going to call C. And you might sort of get the feel when you're looking at this that I'm sort of hand waving a little bit on my drawing. And I am a little bit because I'm not actually asked to draw on most of the graphs that I'm doing. But here's the deal with what we're doing with hyperbolas. Hyperbolas have a B value. I'm not drawing it in here. But the A value and the B value actually create, and in this particular part your book's not asking you to do it, they create asymptotes. And our graph of our hyperbola is actually trapped between these asymptotes. And the B value actually tells you how wide or how narrow those asymptotes are as to where it's going to trap the two pieces of the hyperbola. Now, there's not a picture for me to sort of draw in with the B value that's going to be especially helpful. So I'm not going to try and draw in for you where the B value actually lies. But there is an equation that we will be able to use as we're calculating that. So let's take a look then at that equation and at the details that it provides. I guess I didn't get it typed in here. I'll write it for you. All right, so the equation actually looks a lot like the ellipse equation. It's x minus x0 squared over a squared. And then y minus y0 squared over b squared. And it equals 1. And the only difference in the equation is that it's subtraction instead of addition. And that subtraction changes the image drastically, doesn't it? And that doesn't look anything like an ellipse, but the formulas are almost identical. So this describes a hyperbola with foci at x0 minus c and x0 plus c, and then y0. So again, this is the very first picture of the hyperbola that I drew. And the c value is a squared plus b squared. Do you see that? How's that different than for the ellipse? What happened when we had that piece of it for the ellipse? It was minus, right? Yeah, it was a subtraction. The hyperbola has a center at x0, y0. And the vertices, again, are along the x direction, the horizontal direction, x0 plus or minus a, and the same y0 value. And then I do actually have asymptotes that I could draw in, and I've written the equation for those. It's plus or minus b over a times x minus x0 plus y0. And unless I'm mistaken, I don't think any of the questions actually ask you to find the asymptotes. So you're not going to need that piece of information. I'm pretty sure. But you do have a formula you can use, and you'll have all the details to plug it in if you were to need to. So this actually gives you that first picture that I drew. It gives you this one that's what we could call horizontal, at least in terms of the description, the axes that we're sort of identifying all our points along is horizontal. The other picture is, it occurs if we actually switch, did I get everything written there right?
That's the ellipse.
Yeah, it is. I think I maybe copy-pasted something wrong. All right, we'll fix it so we can, I'll fix it like permanently later. I think it copied in the wrong piece. Oh. Oh my goodness, what in the world? Oh, some crazy stuff. All right, let's just pause with what's going on. This isn't what you've got. I'll tell you what the details are. I'll use a clean screen. All right, so if we reverse the equation, it would mean that we've got the y values in the front and the x values second. So the equation reversed would look like this. It would actually have the y minus y0 first, and it would have the x minus x0 second, and it would be equal to 1. And we would have the squared values underneath. So we'll write a squared and b squared here without moving them. I'm sorry. I think we want them to be written the way I had before. I don't remember how your book does it. We'll leave it as b underneath y and a underneath x to keep consistent with what we did before. The basic idea is if the equation is reversed, the ratio has y positive and the x's are negative, then you end up with foci. I'll help you fill in your blanks. At x0, and then it's y0 minus c, and x0 and y0 plus c. The center is still at x0, y0. That doesn't change. The vertices are at x0, and then y0 plus or minus a. I think that's how I did your notes. Does that look right? I made a change to mine. And your asymptote is almost the same asymptote that you had before, except that it is plus or minus a over b instead of b over a. Like I said, I'm fairly certain none of the questions that I've assigned had anything asking you about the asymptotes. All right, so let's look at an equation. Here's the one I think we're supposed to be on. And this one says, find an equation for the indicated conic section, just like we have had the directions before. But we've got a hyperbola. They have foci at negative 2, 2, and at 6, 2, and they have vertices at 0, 2, and 4, 2. So what are you going to do? Draw it. I mean, we're at least going to plot these points. Whether we finish drawing the hyperbola or not, we may not need to, but at least to plot the points helps give us a lot of direction in creating the equation. Now, this one actually does have some negative values, so I need the negative x-axis at least. So I have negative 2, 2. I have 6, 2. And then I have vertices at 0, 2. So I'll do that in purple. And at 4, 2. So which formula do I have? Do I have the x's positive or the y's positive? Do you know? It is x. So those purple dots, those are the hyperbola vertices, which means the direction of this opens something like this, with the black dots being the foci located inside of the branches of the hyperbola. So my hyperbola needs to have x first in order to get it to be having this axis along the horizontal. It is subtraction because I'm doing an ellipse. I'm not doing an ellipse, I'm doing hyperbola. Here we go. All right, I need to know the center. Now, I haven't marked it yet, but do you know what it is? It's 2, 2. You betcha. Right here, halfway in between my vertices, halfway in between my foci, it's 2, 2. So I've got this 2 here and this 2 here. And then the value that goes underneath the x is the distance from the center to the vertices, or to one of the vertices anyway, which would be the total of 2, which then would square to be 4, right? Because then if x squared, or a squared underneath there, 4. And then just like I did with the ellipse, there's this relationship, and the relationship is that c equals the square root of a squared plus b squared, right? What's C in this problem? It is. It's 4. C is the distance from your foci to the center, and it's 4. So this is 4 equals, and then a squared is 4, or 2 squared, which would be 4, and then b squared here. Do you know what b squared has to be to make this work? It has to be 12. All right, so if you aren't sure how to see that visually, you can work it out pretty quick. You're squaring this. This is 16 equals 4 plus b, so what's b going to have to be? 12. Do you see it now? Okay, so the 12 goes underneath the y value. And the reality is I don't really care what a and b are defined to be. It doesn't make any difference in this particular problem, right? It really doesn't. I've got the value underneath x, and I've got the value underneath y. All right, you ready to take a little bit of a different direction now? Initially, we were given information, and we were told to create equations. So the next thing we want to do is I want us to take an equation and try and figure out which type of graph I have. And we're going to find the vertex and the directrix and so forth as we do that, okay? And we may or may not, oh, I don't even have 4 written in here somehow. Oh, for pity's sake, what did I do? My goodness. All right, we'll write 4 down. When I create these, I create PowerPoints and then I take pictures of the slides. And so what happened was the pictures of the slides got messed up to get this to happen, just so you know. All right, so here's what I've got. I think. Did I write it in there right? All right, what is this an equation of? Hyperbola. This one's actually pretty clean and easy to see because it's already in this sort of standard form of a hyperbola, right? This is a hyperbola. It asks me for the vertex, focus, directrix. It doesn't ask me for the center, but just for fun, let's find it first because it's the easy one to find. What's the center? 1, 0. And I need vertices. So, any idea what I might try and do? The 9 right here? Close. So square root of 9, which is that what you said? Okay, yeah, 3. So this right here is going to be the distance from the center, which is why we identified it, out to the vertices. And it's going to be along a horizontal because the x is listed first. So in terms of a picture, the image that some of you are already doing, and I know you're doing it because you're describing it in this way already, is you've got your center at 1, 0 here. And you know that your vertices have to move away from that point, and they have to do it along the x, the horizontal direction, because x is listed first. So I'm going to move out from there. What did you say, James?
3.
Right, 3 points. So visually, I don't even need a formula, right? I mean, like you can either visually write it in or you can calculate it with just using some simple addition and subtraction pretty quick. What are your vertices? -2, 0, and 4, 0. Exactly. Oops, not 400. 4, 0. It also asked us for our focus, or foci. In this case, it's foci because there's more than one. How do I find that? That's going to require a little bit of work. I need to find C. Exactly, Michael. So do you know how to find C? Right, C equals the square root, and it equals the square root of the 9 and the 4 subtracted, right? And it's really just whatever the larger one, and not subtracted, added, I think, yeah?
Yes.
Added, yes, thank you. And so it doesn't even matter what order we do that in, because it's addition. So this is 9 plus 4, so what is C? Yeah, it's the square root of 13. So if I'm doing my foci, I can take the center value for x, which is 1, and then I can add or subtract that C value, which is square root of 13, to those particular points, or to that particular coordinate of the point anyway. Yes?
On stuff like the vertice and foci, can we just write plus or minus?
You can if it doesn't simplify.
Okay.
Like, for instance, on the vertices, if we wrote 1 plus or minus 3, I mean, that's just goofy. Agreed? Cameron? It's goofy. If I had this piece right here and you wrote down for me that this was 1 plus or minus 3, 0, that is incomplete. There's no way I'm going to let you stop there. That's silly. But if, it makes perfect sense to leave it when we got the square root of 13 because I can't simplify that anyway. Okay? All right, let's do another one. That one that we just looked at was nice and clean because it was in a form that matched things we'd already looked at, and this one isn't. All right, so however, just by looking at it, you should be able to tell without moving anything around on this one what it is. It's not a hyperbola, it's a parabola. Micah seemed pretty convinced when he said it. What convinced you, Micah?
There's only one squared term.
There's only one term that's squared. Yeah, if there's only one term that's squared, you're working with a parabola. So this is a parabola. All right, and then we're supposed to identify all the different pieces. Oh, I did say directrix on the last one, and I didn't do it, did I? And I was doing a hyperbola. So maybe we should go do that real quick. I'm sorry. I didn't get that direction down because I didn't have my directions written since I missed that piece of it. So I did have actually assigned you something with that, with a way to find it, or a question that asked you for the directrix. I didn't write that. All right, so y equals. From the directrix formula that we had on the previous slide, the x0 and the y0 are still your points from your center. So this is x minus 1, and this is then plus 0. And then you've got plus or minus the b value, which is the second value, okay? Let me make sure we got it in there right. Yeah, the b value over the a value. So here's what I'm looking at right now. And in particular, you can ignore the b and the a version of this. It's the second one, the subtraction one, divided by the addition one, the added one, the one that's positive. Yes, that's exactly right. Your directrix is, well, that's not true. Your directrix is usually for your parabola. These are asymptotes. The directions may not ask you for the asymptotes then. That may be true. Let's write it down since we started it. The a value, what did I find, was 4, or 9 rather, right? And then the b value is 4, so this is 4 of 9. Is that right? Oh, you're right. It is the square root, not the square. So 2 and 3. The subtracted value is the one that's from the second term is on the top, and the one that's from the first term is on the bottom. That way, anyway, we've done one of them if they ask you to find the asymptote. So my apologies. I don't know if they asked you to find the asymptote or not. They didn't on this particular one the way I wrote the directions in. Okay, let's do this again. Let's go back to that parabola when we were looking at example 5. There we go, parabola. There's lots of ways that we could handle doing this problem. I'm kind of a big fan of let's put it in standard form because we can identify a lot of the pieces if it's in standard form, whereas the form that it's in right now looks a little bit messy. Do you guys okay with that? Does that sound cool? So the parabola standard form means it's solved for y equals, and it means that the part, or x in this case because x is the one that's not squared, and it means the part that is squared, which is written as y minus 1 quantity squared, doesn't need to be distributed out. I don't have to FOIL that or anything. So what I am going to do is I am going to write this as 4x plus 8, and I am going to move the y minus 1 squared to the other side, which will then make it positive. I can subtract my 8 and then divide by 4. So if I subtract my 8, I have negative 12. And if I divide by 4, I get 1/4 y minus 1 squared, and then minus 3. So this is my standard form. And I like the standard form because I can see a lot of the pieces. For instance, the vertex here, I can see it. What is the vertex? Do you remember Parabolas enough to remember where the vertex was? We did that last time, not this time. Yeah, it's found by using these values right here. The 3 value is associated with x because it's the one that's on the other side. So it is -3. It's the same sign as that one. And then the -1 on the inside or the -1 on the inside, you use the opposite sign for it, so it's +1. So the vertex is -3, 1. Any idea how this parabola opens? It didn't actually ask us to draw it, but do you know how it opens?
Right.
It opens to the right, exactly. So this image does something like this, and it's doing this at the point -3, 1. So it's opening something like that, right? That is a terrible picture, but you can imagine. I'm asked to find a couple of other things. What am I asked to find? The focus and the directrix. Actually, finding the focus and finding the directrix is a very similar process. How do I find either one of them? What is it involved in me doing this? From the parabolas. Do you have a question? All right. Right. Yes, you're exactly right. We're going to figure out how far right and left from the vertex we need to go. How do we figure out how far right and left we need to go? Do you remember? Yeah. It comes from the coefficient in front of my squared term, the 1/4. In particular, that, let me go back to this because we haven't seen it for a couple days now, for my picture. In particular, the distance that we are away is 1/4a. The a value is what I'm looking for, right? Not the distance isn't 1/4a, but the a value is what I'm looking for. So how far am I away? It's 1, isn't it? My a value is actually going to have to be 1 because I've got a 1/4 already in my problem. Too far. So my a value here is equal to 1. So how do I get my foci? I think I wrote the foci down on this one. It's not even foci, it's focus because there's only one. How do I get my focus? Yeah, it's this point that I've got right here, which, Jordan, you're the one who said that that was the x value that we're going to be working with, right? So the x value right now is -3. And I'm just going to add the 1 to it because I need to be to the right of it. It'll be right here, yeah? So what is that point going to have to be? -2. Yeah, our focus at -2, 1, right? What do I do to find the directrix then? Yeah, so I'm going to go the opposite direction that I went from the focus, right? So I'm going to go left in this case. The same amount, 1. So visually, this is my directrix right here. And if I go left 1, and it is a vertical line, so it's x equals what? -4 is correct. So my directrix is x equals -4. Pictures are great. All right, one more. An ellipse. Identify the conic section and find the vertex. Oh, man, I totally gave you the answer already from the first part, didn't I? You knew it was an ellipse, though, right?
Yeah.
How do you know it's an ellipse from the graph that or the equation you're given?
It's adding.
It's adding, and they're both squared. Exactly. So we're going to actually go ahead and change this into the standard form by dividing all the pieces to get a 1 on the right-hand side. So this is x minus 2 squared. And if it helps you, you can actually write this divided by 3 squared, because that's 9. This is actually y squared over 1, or 1 squared, and this is equal to 1. Let's find the details really quick. What's my center that I'm going to be using as a reference? 2, 0 is correct. Is this going to be a, for lack of better terms, horizontal ellipse or vertical ellipse? Will it be longer horizontally or vertically? Horizontal, how do you know?
Because the number under the x.
The number under the x is the bigger number. That means that's how I'm going to find my vertices, right? Is the number underneath the x. What do I do to find my vertices? I use this number. How? How do I use this number? Yeah, I take that value, the 3 part of that, right? That's being squared, and I add and subtract that from 2. So one of them is going to be 5, and the other one's going to be -1. Agreed? And then to find my foci, I actually take c. It's going to equal the square root of the, in essence, the larger number minus the smaller number. Otherwise, we're going to end up with something non-real, right? So this is going to be 9 minus 1. Square root of 8. Somebody simplify that for me.
2 square root of 2.
Very good. 2 square root of 2. So what are my foci? 2 plus or minus? Yep, 2 square root of 2. Thank you. And then 0, right? All right, that's it. I didn't even draw a picture on that one. Man, wasn't that a crazy thing to do? Me and my pictures.